right. In theory, we should be live. And in theory, this should look a little better. So we did a bunch of tests over the last week, figuring out how to improve the green screen software in our streaming software, not having to run through Zoom the way I was before. So now it's a little better. Yeah, Nancy, you don't need to dial in now onto Zoom. Because I'm not using Zoom anymore. I'm just using OBS, so it should be a lot better. And we're going to record locally, so now we should have a much better quality of audio and video for the episode that Chad actually edits. All right, how's everybody doing? Okay, so let me start the recording. Okay. If you're wondering, that's Planet 9 behind me, which is kind of cool. Yeah, I'm recording the audio locally and I'm recording the video locally, Chad. So everything should be good. So hopefully, the big question is whether the camera will overheat. So if the camera overheats, then we've got the backup. But the trailer's pretty cold, so I don't think it will be a bit of a problem. And people were asking me, I posted a video of the builders pouring the concrete walls of the studio. So if you wanted to check that out, it's on YouTube. It's a story. I don't know what they call them. Anyway, shorts. I'm not sure. It's all mushing together in my head. Like when I post a video, do I do just a video? Do I do a story? Do I do a short? Do I do a TikTok? What do I do? All right. Okay, so let's get into this week's questions. Let me just get everything set up. Recording reminder. Yes, I am recording, Chad. Okay, excellent. And then upcoming interviews. I'm still trying to schedule this interview with the guy from NASA on doing sample return missions from Mars. And I'm also scheduling an interview with someone from the Pulsar Timing Array, which is a new method of measuring gravitational waves using pulsars. It's really cool and should be able to give us some of the like merging supermassive black holes, primordial gravitational waves. So it should allow observations of gravitational waves in other kinds of events. But I've been on quite a gravitational wave kick recently. We've been reporting quite a bit on Universe Today about it. So I've got a lot of stories I've been watching. All right. Here we go. All right. Hey everyone, welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. Now, I normally promote this at the end of every single show that we do, but I just want to remind you that every week I write a very large email newsletter that breaks down all of the interesting space news that's happening in this week. All the stuff we're reporting on Universe Today, plus just like every single space-related story that caught my attention. It's all there. There's cool pictures. I write every word. There's no ads. It's totally free. So if that's of interest to you, you want to stay on top of all the space news, go to universetoday.com/newsletter, and then you can sign up and join the 50,000 other people that get this newsletter every week. All right, let's get into the questions. Okay, so I've got some prepared questions, and then we'll get into the live questions. So go ahead and hammer any questions that pop in your brain, and we'll tackle them after we do this. All right. Okoro, how long into the future could life survive? Any hope to make it past 100 trillion years? There's a bunch of constraints to this question. You're asking, like, how long would life survive? And I guess the answer to that question depends on life where. So life here on Earth has only got about 500 million years left. The sun is slowly heating up, and over the course of the next 500 million years, the temperature will rise to the point that all the water will boil on the surface of the planet, and so large surface life won't be able to exist on the surface of the Earth anymore. Now, life could still exist, say, at the bottom of the ocean, deep underground, but then all that water, eventually the planet will warm up to the point that it's really uninhabitable except for really, really tough bacteria hiding several kilometers down below. So we've got about 500 million to about 1 billion years left, which is surprisingly short when the sun isn't going to turn into a red giant for about another 5 billion years. So really, we've only got, about 500 million to 1 billion years left. It has nothing to do with global warming. It's just this natural heating from the sun over vast time scales. So, but then I'm sure what you're wondering is how long will life survive anywhere? And for that situation, you really need a star. And so the longest lived stars that are out there across the universe are going to live, they're let me do this again. Red dwarfs are the longest lived stars out there. And so let's assume that all of the red dwarfs that are going to form in the next few billion years, and then they're going to live for 10 plus trillion years. And so theoretically, you could have life around a red dwarf star that would form in the next few billion years, and then it would support habitable life for, say, 10 trillion years. Beyond that, there aren't a lot of sources for places where life could exist. Theoretically, you can have planets remain in orbit around white dwarf stars as the white dwarf slowly cools down. You could have planets orbiting around black holes for vast periods of time, although you would probably expect, there's a lot of radiation in the environment, so you'd probably need some kind of intelligent civilization that can deal with all of the hazards that are coming out of the black hole. But if they're able to feed the black hole with material, you can imagine a civilization living around a black hole for hundreds of trillions, quadrillions, quintillion years, a long, long way into the future. Really, the limit is going to be, when do the black holes evaporate? And that's going to happen in about 10 to the power of 100 years. A Google years from now, all of the large black holes will have evaporated, and there'll be no sources of heat, of energy left in the universe. As well, possibly, all of the protons in the universe may decay, and so the very matter that life would be made out of would disappear. But that's a long time. Even 1 trillion years, 10 trillion years, 100 trillion years is a pretty long time. But yeah, I would say reasonably naturally, life will exist in the universe for another few trillion years at this point. Okay. Jeff Wilkie. Given enough time, a black hole supposedly evaporates. Once enough evaporation has taken place, will the event horizon disappear, revealing a dense ball of mass, possibly a neutron star? I guess the evaporation will stop there. You're right that black holes will evaporate over vast periods of time. And from an outsider perspective, looking at a black hole and watching as it evaporates, what they're going to see is particles emanating from the event horizon of the black hole. The vast majority of those particles are going to be photons. They're going to be light, heat, temperature. And so what that means is it gives the black hole a temperature. Right now, any black hole that we could possibly look at is going to have a temperature that's essentially the same temperature as the background temperature of the universe. But over time, as the black hole evaporates more and more, that temperature goes up. And once the black hole reaches, say, the mass of an asteroid, the temperature is like room temperature. And as it gets even smaller, less massive, it gets hotter and hotter and hotter. And eventually, the black hole gets the mass of a house. It's reaching millions of degrees. It's blasting out gamma radiation, and it sort of gives off one final burst of gamma radiation, and then it disappears completely. So no, you don't end up with some remnant as the black hole is evaporated. It just heats up, gets higher and higher temperature, and eventually it just completely disappears. Oh, and astronomers have actually gone searching, or let me do this another way. Astronomers have actually proposed that this is a way that you could detect if there are smaller mass primordial black holes out there across the universe. Maybe we can detect these pops of gamma radiation as these black holes disappear. Right. Craig O'Brien. Do you think we will have more chance of detecting biosignatures or technosignatures? In the search for life across the universe, there's sort of two main classifications. Biosignatures, where astronomers are looking for some kind of evidence that life exists, some impact that life is having on its planet. So you could see various gases in the atmosphere like methane or oxygen or ozone. You could imagine there'd be certain wavelengths of light coming off of the planet, which could be due to, say, photosynthesis, plants, things like that. You could imagine if you have a powerful enough telescope, maybe you could even see forests. You could see various life-caused structures on a planet. And then a subset of biosignatures is technosignatures. And that is the kinds of evidence that intelligent life might give off across the universe. So you could imagine aliens shooting a laser beam or radio signals directly at us, aliens that are polluting their atmosphere, and we can detect the chlorofluorocarbons or various pollutants in their atmosphere. Maybe aliens who have vast cities and they illuminate the night side of their planet. There's been a ton of really great ideas on how we might be able to detect some technological civilization. So you're asking, like, which one do I think that we're going to detect first? It's tricky, actually. Searching for biosignatures is going to be sort of more, let me see a way to put this. It's tricky. When you're searching for biosignatures, say you're pointing the James Webb Space Telescope at some Earth-sized world and you're detecting methane or phosphine or some other chemical in the atmosphere of that planet. You're saying, okay, there's life there. Well, as we learned with the discovery of phosphine in Venus, or not discovery of phosphine, as we've learned with the discovery of methane at Mars, the results are really inconclusive. And Mars and Venus are right here in the solar system with us. So if some future team of astronomers announces the discovery of vast amounts of oxygen or methane in the atmosphere of some other planet, it's going to be really hard to know definitively that they actually did find life. It's just going to be, astronomers are going to argue for decades about whether or not they're going to create bigger space telescopes, and they're going to try and do follow-on studies, and they're still going to try to find, but it'll never be conclusive. But on the flip side, if we receive a radio signal from some intelligent civilization, it's unambiguous. There's no question. There's no way that nature can produce the kind of signal that SETI astronomers are looking for from intelligent civilizations. There's no way that a natural phenomenon could create a giant triangle-shaped space station going around a star or a planet. And so it's kind of tricky. I think that there are way more tools and methods, and people are going to be searching for natural biosignatures from life, and yet the results will be very inconclusive. And then on the other hand, you've got a few people who are searching for technosignatures, and any one of them that you find is sort of a slam dunk that tells you, yes, not only is there life there, there's intelligent life there. So it's tricky. I'd be interested to see which one. If you forced me to give you an answer, I think that we will detect biosignatures, inconclusive biosignatures first, before we detect a technosignature. Okay. Mitch Harpino, everyone asks Fraser space questions, but never asks Fraser how he's doing. How are you, Fraser? Dumb question. Maybe it was in between the galaxies. Wait a minute, that was another question. I'm doing good. Good. I mean, trailer life sucks. I think people always ask, I don't know, people have these romantical notions about living in a trailer, and they just think it's so cool. Living in a trailer in the forest, that'd be great. But we're battling mice. It's very damp. The technology in a trailer kind of sucks for just like having showers, going to the bathroom, using water, washing the dishes, heating the place. So I cannot wait to shift out into a more permanent home. But apart from that, I'm surprised how well I've been able to make all this work. I mean, yeah, I had to shift to an actual green screen, which causes me no end of shame. But apart from that, I'm still kind of doing everything that I did before. Just I have different routines now. I I go and I use our car. So I have a Leaf, and I go and sit in the car as my office because Carla's still sleeping. You know, I get up at 5 in the morning, and Carla likes to sleep until 9. And so I'll go and just get out of bed and go into the Leaf and sit and work for a few hours. I turn on the heat in the car. It's comfortable. It's battery powered, so it works great. And then I just plug it in again and recharge it up. So I sort of have a mini office that I work from. And of course, it's beautiful around here. I mean, it's just, you know, all kinds of nature, deer, really cool birds all around us. So it makes up lots. And now sort of we're in fall, the leaves are turning. So I get to have a lot of really great places to go and walk and be out in nature. And at the same time, have internet thanks to Starlink. So yeah, things are good. Arjone, how was Canadian Thanksgiving? Did you have turkey? It was, you know, like again, like trying to cook anything interesting in this trailer sucks. It has a tiny little oven, didn't bother. So no, we didn't do anything interesting for Canadian Thanksgiving, except I took the day off, which I always do every year, which is why there was no show last week. All right. All right, I'm going to answer Larry's question here. Larry Beckham, will Lucy make it? For those of you who aren't aware, NASA just launched its Lucy spacecraft. This is the one that's going to be visiting 8 separate asteroids as it passes through Jupiter's Trojan asteroid field. It's going to pass through one. It's going to fly through the asteroid belt, then up to one of Jupiter's Trojan belts, and then fall back down into the inner solar system, do a flyby of Earth, get a gravitational slingshot, go back out to Jupiter's other Trojan region, and take some more images of asteroids. 8 asteroids for one spacecraft, which is really good, sort of cost savings. The mission launched just a couple of days ago when I'm filming this, and unfortunately, we've learned that one of the solar panels deployed well, but the other solar panel has failed to latch. And so it hasn't clipped into its deployed position and is free hanging and can rock back and forth as the spacecraft makes orbital maneuvers. I don't know if they're going to be able to solve this problem. I'm assuming they will. Maybe they're going to have to do some kind of quick twist to try and sort of clip the solar panel in place. But if not, they're going to have to be really careful working with the spacecraft as they turn it, because you don't want to make the solar panel arm fold back in and not function. Lucy has gigantic solar panels, and that's because it's designed to operate farther from the sun than really any spacecraft ever has before. It's way out in the orbit of Jupiter, and even past the orbit of Jupiter, farther than Juno is. And so it really needs full solar panel operation for it to survive. So now it's time for all the NASA engineers to come up with some clever solution to deal with what could be a crisis on the spacecraft. Oops. Okay. The Planet Repairman, if the universe is made to bake an apple pie, when do we eat? Like some future apple pie? I don't really understand the question. Fugal Creations is a red dwarf. Let's see. Fugal Creations. Could red dwarf stars become less hectic with time? We've talked about this a bit in the past, that red dwarf stars seem to have really powerful flares, things that are, say, 100,000 times more powerful than the kinds of flares that we have here with the sun. And we've seen in the past that very powerful solar flares can be very disruptive to at least our modern electronics. But if you had a flare that was thousands of times more powerful, delivered more radiation, more particles, things like that, it would actually strip the atmosphere right off of a planet. And so the thinking is that when red dwarf stars are fairly young, as these flares are constantly being blasted off into space, they are stripping away the atmosphere of any world, any Earth-like worlds, destroying any water that they have on them, and really making them uninhabitable. Sure, a red dwarf star will settle down over the course of a few hundred, a few million years. And then from that point forward, it is a great place to be set up around. The red dwarf sort of sips at its energy for long periods of time and could live for 1 trillion, 10 trillion years. That gives life a long time to be able to set up shop and try to survive. Now, the wavelength of light, like even though you could have a planet that is warm enough around a red dwarf star, it's not actually getting a lot of energy landing on the surface of it, not the kind of energy that we have here on Earth. And so it could be argued that it's not like a great place for photosynthesis, things like that. But still, we sort of don't know what the extremes of what life could do on a world like that. Now, there's been some really interesting research that just came out, and sort of the reason I wanted to take this question is in the last week or so, astronomers announced that they detected radio signals coming from red dwarf stars. So they had these red dwarf stars, and they noticed that as they were producing flares, they were also getting some kind of radio waves that were coming our way. And what astronomers realized is that this is the flare interacting with the magnetosphere around a planet orbiting that red dwarf star. And they found like 4 or 5 of these already. So they're literally detecting planets around red dwarf stars. They can't see the planets, but they know they're there because they're detecting how the flares are interacting with the magnetospheres of their planets. And as we know, having a magnetosphere around your planet is one of the ways that Earth protects life here. That with our magnetosphere, as the flares come off the sun, the particles are redirected by the magnetosphere to be harmless to life down on the planet. And so it could very well be that if a planet can build a very powerful magnetosphere early on, maybe it can survive, even when the star is being very disruptive. So it's quite an exciting discovery. And I love this idea that you are discovering planets because they've got a protective shield that could be supporting life. It's a pretty exciting discovery. All right. Paul Took. Where does the energy go if the universe becomes static and scientific law says that energy can't be destroyed? Over time, as the universe expands, the amount of energy, essentially the density of energy in any one space, is going to go down. So say all of the energy that was in the universe was enclosed within, say, our observable universe. And as our observable universe gets larger, right, all of the energy just stretches out into fill larger and larger spaces. So all of the energy that was ever here at the beginning of the universe is still here, and it will always be here. It'll be here far into the far, far future. It's never going to be destroyed. It's just going to be stretched out. and the temperature differences. That's really the key, is that, when astronomers call the heat death of the universe, what they're saying is that there will no longer be any usable heat, no longer any differences of heat that could be extracted to do any work. And so right now we have, say, stars that are tens of thousands of degrees on their surface. And then we have space itself, which can be close to absolute zero. And it's that difference in temperature that you can work with. You can grow plants, you can have machines, etc. But over time, as the stars cool down, as the planets cool down, as the black holes evaporate, everything will end up being roughly the same temperature. And as soon as you have those temperature similarities, there's nothing you can do to any work. And so life can't exist, technology can't exist, computers won't work, there'll be nothing left. And that's the heat death. Let's see. Okay. Dr. Ed Elcott, cryptozoologist. James Webb will see in the infrared. Will this help us detect more brown dwarfs? And do brown dwarfs have similar lifespans as red dwarfs? Yes, James Webb will be able to observe brown dwarfs, but it's not the best machine for that. The real machine for detecting brown dwarfs was the WISE survey, which actually was a spacecraft that was launched like about a decade ago. And its job was to search the environment for brown dwarfs, really what its main goal. It's been put into work as sort of a secondary job now to search for asteroids. But originally, in fact, people always ask, could there be a brown dwarf that's in orbit around the sun? And this mission, WISE, was able to determine that there's nothing Jupiter-sized, nothing Saturn-sized out to probably a couple of light years of the sun. So there is not some large Jupiter object out there in the Oort cloud somewhere. We know that fairly certainly. And WISE was able to turn up a whole bunch of other brown dwarfs. And so, in fact, a bunch of brown dwarfs are named WISE and then a bunch of numbers after that. So James Webb, if you knew where you wanted to look, you could point James Webb, this really powerful telescope, and look at this brown dwarf. And in the infrared spectrum, it will be able to make observations that'll be really hard for other visible light telescopes. But it's not going to be a finder in the same way. You need a survey, which was what WISE was. Something like the Vera Rubin Observatory, but searching in infrared as opposed to searching in visible. So brown dwarfs, do brown dwarfs have the same kind of lifespan? I mean, brown dwarfs are already a lot cooler. Brown dwarf is going to be like hotter than Jupiter, but cooler than a red dwarf. They don't have proper hydrogen fusion going on in their core, and so they will be not very detectable over just the background cold of the universe, which is why they're very tricky to detect. But what makes them pretty exciting is you could imagine having a planet that is orbiting around a brown dwarf, maybe tidally locked to the brown dwarf, in the same way that, say, Europa or Enceladus are tidally locked to their, like Europa is tidally locked to Jupiter and Enceladus is tidally locked to Saturn. And so through those tidal interactions, the moon, in this case the planet, would remain liquid under some kind of icy ocean. As you can imagine, there could be life on one of these worlds. And so brown dwarfs are still very interesting places to go and look, but they're already cool, and they're just going to get cooler over time. Let's see. Okay. Oh, that was Chad talking to me. Let's see. No, what green screen? Exactly. Michael Booth, have you got a good spot in the forest there to do some astronomy? Yeah, where we are is actually a very large cleared spot. It's about 3.5 acres that's just completely cleared. And we've got a view to the south. So I do plan to build a little observatory and set up a telescope. And then I'll be able to properly stream the night sky on the one day a year that it's not cloudy and rainy. But yeah, the sky's great here. We're really well positioned. Now the trees are growing quickly, but yeah, it should be good. Let's see. Romulus XC. Hey Fraser, are we able to detect if any wormhole opens in our solar system? In the TV series Another Life, they detected it instantly. So a wormhole is theoretical. Let me start this again. Obviously, wormholes, they're a staple of science fiction. Stargate used wormholes. Interstellar had wormholes, and I guess Another Life, I haven't watched this yet, if they've got wormholes. This idea that you've got some kind of connection in space-time between two places. And so I guess the question that you're asking is like, would we know if there was a wormhole? And in most situations, the answer would be no. No, we wouldn't be able to detect. Because imagine, like if a wormhole is just a window to another part of the universe, then you would just be seeing, say if the wormhole was passing through your field of view, you would be seeing out the other side of the wormhole, and theoretically you would just be seeing more universe. There was a paper that I read, I think we reported on it again in the last year or so on Universe Today, that you can have certain situations where one end of a wormhole is, say, orbiting around a black hole. And in that situation, you probably would be able to detect it because the black hole would be distorting the light and the space-time around it in sort of the same way when you look at a black hole and you see the way light and stars are distorted around the black hole. And so if you had a wormhole and then on the other end of the wormhole was a black hole, then you would see through this tunnel and see the distortion that's on the other side of it. But in general, no. If there could be 1,000 wormholes here in the solar system and we wouldn't be able to spot any of them unless something really interesting was happening on the other side of it. But you can imagine situations where, say, stars would appear and disappear, or planets would appear and disappear, and that would be a pretty big clue. So it really all depends on what's on the other side of the wormhole. Larry Beckham just learned about giant hogweed. Scary stuff. Any near you? Yeah, we have giant hogweed here. It's like 6 feet tall. It's like corrosive on your skin. Like if you get the stuff on you, it's very, very bad and poisonous to eat. It's a very dangerous plant. But I've never seen one. We have smaller versions of hogweed, but they're all in the carrot family. But water hemlock is in like the same stuff that was it Plato used to kill himself, was sort of a similar kind of plant to giant hogweed. It's like one of the invasive plants that we have here in British Columbia, and so whenever you see it, you have to report it to conservation. Would it be possible to set up a primitive gravity telescope on your property, like a little mini LIGO? No. Will your new observatory mean virtual star parties? Yeah, when I set up a telescope, I will definitely do virtual star parties from that, because then I have total control over the telescope. So, but I'm trying to think when I'll do this. Probably in the spring. Hopefully, I'll be able to set something up. Okay. R3 Conwu. Anything interesting with the Chinese space program lately? Yeah, the Chinese have been very busy. Of course, they launched their space station several months ago. The first crew, the first three-person crew to the space station has already come and returned back to Earth. And the second crew to the space station just flew, including a female astronaut. And they're going to be on the station for about 6 months. So they're going to have a much longer term mission. That's like the big accomplishments that have happened. I haven't heard any more news from their rovers. There's been a flurry of news from the sample return mission that they brought back from the moon. They've been handing out samples of the moon. They've been analyzing it, and they've been handing out samples to various researchers around the world. And some of the big discoveries that have been made, they've been able to put a much more accurate date on when volcanism ended on the moon. And it seemed to have lasted a lot longer than anybody thought. It's surprising how much interesting material is mixed in on the lunar regolith, and they weren't expecting this. You've got bits of lava flows, you've got bits of meteorites, you've got chunks of mountains that were nearby. It's all blended together into this regolith sample, and so it's been quite interesting as the researchers have been working through it. So those are the big updates from the Chinese Space Agency. We're still waiting to find out when more nations are going to join on their space station. I know they have plans. They have a partnership with the Russians, and they're sort of inviting other countries to send astronauts up to their station. So it could very well be that we're going to see astronauts from other countries who've never had an astronaut before flying to the Chinese space station. So we'll keep an eye on it. And when something interesting happens, I'll let you know. Zach Perry, if an ice giant melts, does it become a gas giant or something else? It's kind of a tricky question. So an ice giant, like here in the solar system, we've got the two gas giants. We've got Jupiter and Saturn, and then we've got the two ice giants. We've got Neptune and Uranus. But what does it mean when you say that they're made of ice? What they really are is a mixture of hydrogen, helium, and then ice, water ice, as well as other kinds of volatiles, ammonia, methane, various things that are all mixed together. And we call them ice giants because if they were, if you took a scoop of them and dropped them in Antarctica, they would be very much like ice. But on these giant planets, under the immense gravity, they're 5 times the Earth's mass, that once you go down below the upper atmosphere, the temperatures start to warm up quite a bit. And so to define it as ice is really strange because it's like ice that is incredibly hot and under immense pressure, and it acts in all these really weird ways. And so what would be liquid water or even like a solid ice under that kind of temperature and pressure behaves very differently. In some cases, it acts like crystalline. In other cases, it can act even like on Uranus and Neptune. They believe that their magnetic fields are generated by ice, and I use the term loosely here, moving or shifting around inside the planets, and it's generating a magnetic field, which is not a thing that water does here on Earth, and not the source. On Jupiter, the source of its magnetic field is from hydrogen acting like a metal. And on Neptune and Uranus, it appears that their magnetic fields come from ice acting like a metal. So to say, like, how would they melt? I mean, if you could dismantle Uranus and Neptune down into small amounts and spread them across the solar system, they would freeze into little balls. But under that pressure, it's ice acting strangely. Tropical Tom Garcia, before you set up your observatory this spring, will you be investing in a fat tire electric mountain bike capable of good traction in the snow? No, I've got a great mountain bike. I really like it. I'd like an electric bike. That'd be cool. But I'm not a huge fan of the fat tire bikes. We don't get a lot of good snow. Riding on snow sucks. So when we have so much good mountains to ride on. So no. Yeah, I may invest in an electric bike at some point. They're still really expensive. They're like $6,000 for a proper mountain bike, when a really good mountain bike is $1,500. And mine is still in great shape. Better shape than I'm in. But I feel a lot better. Like, I know, I talked about this like last few months that I wrecked my hip flexors riding my mountain bike, and I feel a lot better. And so I'm probably going to get back on my mountain bike in the next couple of weeks, but take it super easy through this winter. All right. Michael Booth, what do you think the challenges will be to filming a movie on the International Space Station? Well, the Russians just finished filming a segment on the International Space Station. A producer and an actress flew with the most recent Soyuz capsule up to the International Space Station, and they spent a week on board the station filming some scene for a movie. Apparently, there's some medical emergency on the space station, and this doctor has to go up and perform surgery while they're on board the station. I don't know how it went. They're back on Earth. They're safe, and they've gone back to shooting additional scenes for their movie. And I don't think it would have happened if it wasn't for generous support from the Russian space agency, essentially underwriting them being able to fly up to the station. Because normally that's a $20 million ticket per person. Like $40 million just so you can shoot one scene of some people on the space station. No way. So the Russians helped pay for this trip up there. What was it like? Well, I mean, in the conversations that I've had with astronauts about what life is on board the space station, a lot of your life is spent in maintenance. You're having to exercise, you're having to deal with all of the machinery, you're having to sort of focus on keeping yourself alive, and then you've got a little bit of time left over that you can do something like, some science experiments, or maybe you can watch a movie. But most of the time you're either just trying to keep yourself alive or you're doing work. And so I can imagine that attempting to shoot your film in space on the station would be tremendously difficult. In all of the tools and techniques, dealing with the lighting. When I just sort of think about what it's like to shoot video here on Earth, it sucks. And so to be in space and you're drifting around and things are floating through the field of view and there's no one helping you with the continuity to remember what the actress's hair looked like, and she's got to put on her own makeup in the middle of the space station and deal with her hair and costume changes and special effects. Is there blood? How they deal with that and how they clean that up? Like, it just sounds like so much work. So I'm looking forward. I can't wait to, when they've actually finished off the movie. I'd love to see it, but it sounds really, really difficult. And I would be surprised if they got a lot of usable footage, even with being up on the station for a week between the two of them. Prince Charming, Ptolemy has recorded Sirius as a red star. Is it possible he saw Sirius B as a red giant? I don't know. Sirius is a very bright blue-white star, so it wouldn't have turned into a red giant. Like, it's not ready to enter that phase yet, so I'm not sure why he said what he said. But maybe the clouds were what? I mean, he would have been very familiar. Sirius is the brightest star in the sky. He would have been very familiar with it. So I don't know. I'd never heard that before. Zach Perry, what's your opinion on the JWST name controversy? Yeah, I'm okay with changing the name of James Webb. I think if assuming the evidence is rock solid that James Webb was a homophobe, then it makes sense to not get a telescope named after him. But so people have been using another name that I kind of like, the Very Cold Space Telescope, which I think is kind of a cool name. But at this point, the die is cast. We'll see what happens into the future. But at least it brings light on whatever James Webb was up to back in the day. Mr. Man, once humans are slow boating between the stars, will 99% of our time be spent playing video games? What kinds of games would be ideal for multi-year voyages? Well, games with a lot of replayability. So RimWorld, of course. That's the best game. David Shannon, should we be afraid of a meteorite crashing through the roof, is what happened recently in BC? All right, I'll do this one. David Shannon, should we be afraid of a meteorite crashing through our roof, as what happened recently in British Columbia? Yeah, in my province, some poor woman woke up to find a meteorite crashing through the roof and landing on the bed beside her. That's scary. Like, it's a big rock. It's like a couple of kilograms for sure. Like, if it had landed on her head, if it just landed 6 inches to the side, it probably would have killed her. But you're probably wondering, like how could a rock that came from space have landed that gently? Like, sure, yeah, it went through the roof, but landed on the bed and didn't go through the bed and didn't go through the floor of the house and didn't create a Tunguska-sized explosion where her house used to be. It seemed like a fairly gentle operation. So what happens is when these meteors strike the Earth's atmosphere, they tend to explode in the air because they get this giant shockwave that builds up in front of them, and the forces cause them to tear themselves apart. And astronomers have actually noted, they saw the trail of this meteorite. And so this is a real meteorite. They saw it pass through the atmosphere. They tracked its velocity and its direction. And so what happens then is once the meteor has passed through most of the atmosphere, or passed through the highest velocity, it gets slowed down, and all these chunks of rock are slowed down, then they fall at terminal velocity. And so the damage that this rock did, imagine you took a rock and you just dropped it from 1,000 feet, and it would accelerate, and then it would reach its terminal velocity based on its surface area and the thickness of the atmosphere. It would definitely punch a hole through a roof, and yet probably wouldn't. If you dropped a rock from 1,000 feet onto a bed, it probably wouldn't go through the bed. It would probably bounce off the bed. I am kind of amazed at how little damage it caused, and I'm glad she wasn't hurt. And I heard from some astronomers that the odds of this they're ludicrous, like 1 in 100 billion. That, yeah, rocks from space are falling down all the time, and yet they're almost always completely far away from any human being. So the fact that one landed that close to a person is astronomical, and they should count themselves lucky that they were almost killed by an asteroid, I guess, by a meteorite. It's crazy. Magnetism versus gravity exoplanets. So Sean Marson, could a planet's magnetic field exceed the strength of the planet's gravity? No. The thing with a magnetic field is it deals with the inverse cube law, while gravity deals with the inverse square law. Am I getting that the right way around? And so magnetic fields fall off very quickly compared to gravity. And so gravity in a very small object, like a magnet, then the magnetism will be tremendously stronger than the gravity of the magnet. But over large scales, the gravity is the thing that's more dominant than the magnetism, because magnetism falls off by the inverse cube law. Brian said, does she get to keep it? Yeah, so she gets to keep the meteorite, and she actually lent it to some scientists. But when they're done with it, she gets to have it back. And it's actually special. I mean, to have a meteorite fall that quickly, and essentially it didn't get contaminated by the ground because it landed on her bed. So it's actually a very useful, it's brand new, very fresh. And a lot of times, like when astronomers see a very bright meteor and they think they know where it landed, especially if it lands in the wintertime and maybe it lands on a lake, then it buries itself in the ice. And so it's very easy to go and recover. And it's really been untested, gone through summers and winters and infestation by bacteria and lichen and things like that. So they're very valuable. And so astronomers are very happy to get their hands on this. So yeah, but she totally gets to keep it. Yeah, of course you get to keep it. But I think she's going to, in the end, she'll probably donate it to a museum. It's a very scientifically useful meteorite. Samurai Hash, when will we start getting data back from James Webb? We've got about 30 days for James Webb to go through its initial deployment. And then once that's done, they'll probably take some first light pictures with it. So I would expect end of January, we'll see the first pictures from James Webb. Cryptomound 5000, if you could pick a moon to visit in our solar system, which one would it be and why? Titan, obviously. Like, you should have asked, and why is it Titan? Titan is the best. Raphael Dominichini, are there Trojan asteroids sharing the orbit of other planets besides Jupiter? Yeah. There are Trojan belts around all of the planets. Even Earth has Trojan asteroids, but the size of the Trojan asteroids depends. I think there's been some detected at Mars. The size of the Trojan belt just depends on the mass of the planet. And so Jupiter can have Trojans that are tens of kilometers across, while Earth can have Trojans that are, say, a kilometer across and smaller. And so, but yeah, absolutely. I think they found them around Venus even. Mr. Mann, what aspects of astronomy knowledge would be most useful for a time traveler trapped in the past? Huh, that's interesting. Like, would you like practical astronomy knowledge? I mean, I guess knowing eclipses, when various eclipses were going to happen, if you could predict a solar eclipse or a lunar eclipse, then you would seem quite impressive. If you knew of events that had happened, say supernovae, that things were going to happen, comets were going to appear, if you knew when those were going to happen, you could be very impressive. But I mean, apart from that, I mean, I can't think of anything that would be very practical and useful, because it's not like anybody would believe you if you said, well, actually, the planets aren't gods that are flying around inside the crystal sphere. They're actually balls like, I mean, maybe if you could demonstrate a telescope, that would, if you could build a prototype of a telescope, that would be pretty impressive. All right, let's do this last one here. Arjun, when we see the galaxy, what class of stars are we looking at? I heard that we would be barely able to see the sun in less than 100 light years. Yeah, almost all of the stars that you see in the night sky are unusual. So when you go out and you look up and you see all those stars, they're actually not normal stars. They are all very bright, very hot stars that are either young stars that are very hot, several times the mass of the sun, or dying stars like Betelgeuse that are dozens of times the mass of the sun, and they're puffed out into red giants. There's some blue supergiants that, like Alpha Centauri, which is only, say, 4.5 light years away, is one of the brighter stars in the sky. But once you get out to, say, 10 light years, 15 light years, 20 light years, stars like the sun would fade away and stop being visible just with the unaided eye. And so all that's left are the stars that are really, really bright. And we can see stars that are hundreds of light years away, thousands of light years away, but all of them are very large, hot stars, and not regular stars like our sun, and not dimmer stars, red dwarf stars. Like, you can't even see a single red dwarf star with the unaided eye. You can't see the closest star, Proxima Centauri, without a telescope. And so we see actually a very skewed version of the night sky when we look up and see all those stars. Okay, so it's almost 6 o'clock, so I'm going to do the bumper and the outro, and then we'll do like a little bit of overtime and go from there. Okay. More questions in a second, but first I'd like to thank our patrons, Don Clayton, Bill Persbisk, and the rest of our 796 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. And then I'll do the outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. And I'll do the outro. Thanks, everyone, for joining. And let me just again here. All right, those were all the questions for this week's question show. Thank you, everyone who asked questions either on the videos or joined for the live show. I do this every Monday at 5 p.m. Pacific time on my YouTube channel. You should be able to see an upcoming event for when the next one's going to be. So if you want to join live, it's about an hour and a half long, so it's much longer than what we edit down and put into this show. So if you want to do that, every Monday at 5. All right, I'll see you next week. All right, and let me stop the recordings. Camera didn't overheat. So I guess all we needed was to have summer end. Okay. Let's see. Nancy posted the upcoming weekly Space Hangout. So what do we got? On the October 20th, Megan Russell. 27th of October, Stephen Alexander. November 3rd, Adam Dipert. And November 17th, Dylan Dong. I don't know who any of those people are, actually, who we're going to be interviewing. So, CryptoMan 5000, where can I buy a telescope with crypto assets? I mean, turn your crypto assets into cash, into US dollars, and then buy a telescope with that. I think, isn't Amazon going to be accepting Bitcoin soon? So if you just hang on like a little longer, you should be able to buy a telescope or anything you want on Bitcoin, on Amazon. Let's see. Uncle Bill Druin, don't forget to like, subscribe, and ring that bell. Ring that bell. Poll 2. How much life can exist on rogue planets, getting by on just distant starlight? So rogue planets, these are the planets that either like just formed in place without a star or were kicked out of some planetary system. The evidence seems to be building that they're going to be surprisingly habitable. That once obviously, like imagine a world like, say, Titan or Europa, but with the mass of the Earth or more. And so you're actually going to have a large radioactive rocky core that's going to be heating up the outer area. You're probably going to have a liquid ocean surrounded by some kind of icy shell. And I did an interview about a week ago on this idea of these Haitian worlds, where you've got a water world, but it's surrounded by a fairly thick hydrogen atmosphere. And these worlds could keep themselves warm to the point that you've got liquid water on the surface, even in the dead of space, without any star for them to orbit. So they wouldn't be using starlight to stay habitable, but there's a lot of other mechanisms, either radioactive heat that's keeping the planet warm or some kind of tidal interaction. So you've got, like I say, a giant Jupiter-like planet, and then you've got an Earth mass world orbiting around it, like Europa going around Jupiter, and you could end up with a world that has liquid water on the surface because of the tidal interaction. So it's surprisingly habitable. And the thought that there could be more rogue worlds than stars in the Milky Way, and many of these could be really close to us, that you start to think of these as stepping stones for us to explore the Milky Way, not having to jump all the way to a star. We may only have to go a light year to the nearest rogue planet and use that as a place to refuel, get more propellant, more supplies before moving on. And so it makes the jumping from world to world across the Milky Way actually a lot easier. Mr. Mann, if colonists are playing RimWorld on the journey to new worlds, I have concerns about the security of the people's organs. Yeah, RimWorld is not a training tool, is just a game. So do not take what you've learned in the game and then turn that into the way you deal with civilians on your colony, on your generation ship. Arjun, what does your area of Canada get its power from? Is it green? Yeah, it's all hydroelectric. In fact, we call our power company Hydro. So we get the hydro hooked up. We have to, I got my hydro bill, and so it's all hydroelectric in British Columbia. Oh, there, and Kim Barron is saying that. Yeah, exactly. Yeah, and then some Raihash is saying in Toronto, in Ontario, they also have a lot of hydroelectric. Yeah, we're all hydro here. Popcorn Power saying easier, you'd have to speed up, slow down to land on the planet, refuel, speed up again, then move on to your next location. Well, not necessarily, because remember, it's all about orbits. So, like, when a ship goes into, like, say a ship launches from Earth and goes to Mars, it takes an intercept orbit from Earth to Mars. And yeah, it has to launch off of planet Earth, and then it arrives at Mars, and then it has to enter the atmosphere of Mars, slow down, and land on the surface of Mars. Now, if you wanted to take off from Mars, then yeah. But say maybe you went into orbit around Mars, then, and maybe have a way of refueling yourself, or maybe you just hit the asteroid belt in that area. So I'm imagining some kind of futuristic, incredible technology that allows you to fly from star to star and take off from planets. The point just being, you only have to go a light year to reach your first refueling point, as opposed to 4 light years or longer. Hail Hydro. I mean, it's interesting. You would think that, back to the question about people playing RimWorld, like, you would imagine people would probably live in pretty interesting virtual worlds for most of the time. But I mean, like, let's be honest, like, we're not going to take our meat bodies from star system to star system. Like no meat is ever going to make the journey away from planet Earth. We're going to send our robots. We're going to maybe send DNA factories. We're going to send our virtual presence, but meat isn't going to make the journey. Kim Barron, during Fraser's interview with Dr. Hirono, Dr. Ono mentioned he knows people working for JAXA. Maybe get some interviews about the JAXA missions. Yeah, I should. Actually, there's a lot of really cool people who are actually working at JAXA that I know. So I will try to set up some interviews with some JAXA folks. James Donahue is working with them, and he's great. So let me see. Let's see. Hail Hydrogen. Ren and BR. Any updates on James Webb? Yeah, people always want to ask about that. So James Webb has arrived at French Guiana at the Kourou spaceport, and safe and sound. No pirates. Got it. I saw some pictures of the telescope being folded up, and they've essentially done an unboxing video, and they're starting to process it in their center. The next step is they will put it inside the fairing. They'll mate it to the top of the upper stage. It's like the upper stage, attach it to the top of the booster stage, and then they're going to launch it. Yeah, we need better telomeres. Exactly. Brains in jars. Let's see. Kaio Diniz, what sky objects make for a great view in the southern hemisphere? Man, you've got so many great objects for view from the southern hemisphere. I mean, the large and small Magellanic Clouds are two objects that we can't even see in the northern hemisphere, and they're like little mini Milky Ways that you can see in the sky. As well, there's a lot, one of the best, a lot of the nebulae, a lot of the stuff that we see just down near the horizon here, like, say, all the stuff that's at the core of the Milky Way. When you're in the southern hemisphere, when you're in, say, Australia or South Africa or South America, that stuff is like directly overhead. And so it's a lot easier to look at. And so I would say the southern hemisphere has better things to look at than we have in the north. The largest globular cluster in the sky is available. The Omega cluster is visible from, the southern hemisphere. Incredible. When I was in Australia, seeing the night sky there, it definitely put my night sky to shame. All right, let's see. Nancy had to up the limit for emoji. Arjun, will you go through withdrawal after the Webb telescope works? No, that's when the science starts to happen. So still, we actually wrote an article on Universe Today about the 30 days of terror that James Webb is going to go through. Nancy Atkinson wrote that. It was great. She had a chance to interview a bunch of the people from Webb as well, so she was able to put in a bunch of their quotes. But once it's done and launched and starting to bring in the data, like, the to-do list for James Webb is gigantic, and each observation that it makes will be groundbreaking. Like, it's hard to describe how exciting the data is going to be from James Webb. It's incredible. All right. I think we'll wrap this up. Thank you, everybody, for joining me this week. Thanks to Nancy for collecting all the questions. Thanks to Chad for hanging out as well, and all the mods. Awesome to have you join every week, everyone watching. And we will see all of you next week. Weekly Space Hangout on Wednesday, Astronomy Cast on Friday, and then the Hangout-a-thon over the weekend. So we've got lots of great content coming your way, so stay tuned. All right. Thanks, everyone. And